section, we're going to discuss the word problems that go with our quadratic functions and their graphs. So usually it's something being thrown or launched. And so it says a ball is thrown upward into the air with an initial velocity of 60 feet per second. Its height, h, in feet after t seconds is given by the equation h equals negative 16t squared plus 60t plus 5. And this is a quadratic because of this second degree. And the equation's given to you. So really, instead of an x, we have a t. So we have a time axis running along the horizontal. And instead of a y-axis, we have an h-axis that tells us the height of the ball. But again, the key point to this graph is that vertex or that turning point. We really need to know where that vertex is because along the t-axis, it'll tell us the time it takes to reach the maximum height on the h-axis. So what type of questions will we be asked with this? So here's our graph again, and there's our quadratic at the top. The questions that you'll be asked are part A, how many seconds? That's here along the t-axis or the x. It's really just asking for the x coordinate of the vertex. And remember, x is equal to the opposite of b, where b is a 60, over 2a, where a is a negative 16. So we'll do the opposite of 60, or negative 60, all over twice the a term, or 2 times negative 16. We go to our calculator and we'll figure out that this is 1.875 seconds along the horizontal, which is usually the x, but in our word problem, it's the t axis. So 1.875 seconds until that ball reaches its maximum height. But what will the maximum height be? Well, just like in our non-word problems, to figure out the y value or the value on the vertical axis, we just plug the x value in. So we're just going to take this 1.875 and put it in for the t in our model. Now, we'll need a calculator to do this. So to figure out that height, we'll just go to our calculators and we'll enter it as it looks. And we would get a 61.25, which again looks really good on my picture. It looks just a little bit past 60 on that graph. So that vertex is at 1.875, comma, 61.25. What does that represent in this problem? After 1.875 seconds, the ball will be at a maximum height of 61.25. When it asks you for the range, you think y values. So in this case, we're thinking the height of the ball. What are its constraints? Or what can the height or the vertical be? Well, I can't go underground. So the height would be minimized on the bottom by 0 and maximized on the top by that vertex height, 61.25. So for our heights range, we would say will be always above ground, h greater than or equal to 0, but we'll never get over that peak or that turning point at 61.25. And that represents the maximum height of the ball.